Naval Undersea Warfare Center Division Keyport's In-Service Engineering Department is open for business. Despite the travel restrictions put in place to fight the current pandemic, our team has found innovative ways to continue our support of the warfighters. We developed a new video training program to facilitate the installation of a new fathometer for the fleet, eliminating the need to travel to the ships, and we are constantly seeking new ways to utilize technology so we can keep providing high-quality support.
Good morning and welcome to our 5th Industry Day engagement session. At this time, I'm going to hand it over to our PTAC partners for a little PTAC plug, and also we have our first—
Great, thank you, Dave. My name is Tiffany Scruggs, and it's a pleasure to help. Can you hear me okay? Sorry about that.
We can hear you now.
I believe all of you are frozen. I'm so sorry if you can't hear me right now. My name is— we're good?
You're going, Tiffany, you're going in and out. Let me see if I can handle this, okay? Okay, so welcome. Tiffany Scruggs, who was speaking, is our State of Washington PTAC Director. PTAC is here to assist small business and primes as you work in government contracting. If you are not in Washington State, you can find your local PTAC at aptac-us.org. We welcome you to seek out your local PTAC for no cost assistance. And I'm going to launch the poll. The first, this is a two-parter. We want to know who is here today. So first of all, what certification or business category are you in? A few more seconds. Only about 40% of you are voting. Oh, I didn't introduce myself. I'm Kathy Kokis. I'm with the Kitsap Subcenter in Washington State. Okay, I'm going to end polling for this so we can keep moving along. Share the results. And as we had hoped, the majority are small business. Then on to part 2. Tell us about your company and small business provider. Excellent. Okay, Dave.
Excellent, thank you. So my name is David Wells, and I'm the Deputy for Small Business Programs at the Naval Undersea Warfare Center here at Keyport. And again, I want to welcome you to our 5th of 6 industry engagement sessions. We're very happy that you're taking time out of your busy day and your schedules to join us for this engagement series. Today, we're going to be providing an overview of NUWC Division Keyport's In-Service Engineering Department. Before I introduce our speaker, we do have a part 2 to the for our who's in the audience. So Kathy, can you launch part 2?
Oh, that was it. It was already in there.
Oh, it was. Oh,
yeah.
Okay. I must have missed that. So thank you. So I'll go ahead and introduce our speaker for today. Today, providing the department overview is Mr. David Coleman. And Mr. Coleman was appointed as the Code 40 department head in May of 2020. Previous to this position, he was the Code 40 Deputy Department Head from May of 2019 to May of 2020. Dave has over 30 years of government and private industry experience serving in numerous supervisory and technical roles. In private industry, he ran his own company, providing software development services, specializing in storage and optical media, and also worked for companies such as Adaptec, Roxio, and Sonic Solutions, where he held the role of Senior Director of Engineering. He first joined Keyport in 1992 as a contractor in Code 20, writing software for several acoustic analysis and processing systems. Mr. Coleman has held positions as the head of the Integrated Warfare Systems Engineering Division in Code 44, branch head in Code 20 and Code 40, and has held roles as the SSA for submarine launched countermeasures, project engineer, project lead for the integration of CVTSC into the LCS ASW mission package, and lead systems engineer for the integration of the vehicle control domain element into the Aegis weapons systems. Dave has a bachelor's degree in computer science from Western Washington University and a master's degree in computer science from the University of Washington. And with that, I'm going to hand the controls over to Dave, and I'll be doing the slides. So Dave, whenever you're ready for me to go to the next slide, just let me know. And it's all yours.
Thank you, Dave. So again, my name is David Coleman. Thanks for the very nice introduction. Excuse me. So before I start talking about the in-service engineering department, I just wanted to spend a minute discussing the breadth of what in-service engineering as a discipline itself is. So it's actually comprised of 17 distinct elements. It's a very, very broad topic. The first one is design support. So in-service engineering is focused primarily on fielded systems, so systems that are past milestone C in the DoD acquisition timeline. And so for design support, the focus is on evaluating design against operational data, identifying defects, identifying design changes that need to be made, suggesting them, and participating in that review process. There's a safety element to in-service engineering, which typically centers around doing safety analysis of engineering change requests, as well as analyzing operational data and defects and mishaps to understand safety impacts as well. There's a strong test support element, primarily supporting COMOPTIF 4 for DT and OT, developmental tests, operational test events, as well as combat system qualification trials and such. There's heavy work in supporting technical documentation, specifications, and standards, from maintenance requirements cards through all the technical data associated with the system. As we start to get performance and maintenance data in, there's an analysis piece to understand how the systems are performing, where the failures are, and what type of logistics support or engineering changes might need to be made. There's also supporting the maintenance engineering aspect of it, making sure that the maintenance organizations have the right engineering procedures, operations, tools, et cetera, in order to be able to maintain the systems. There's a software support element. There's a heavy installation element of installing systems onto ships and submarines. There's a fleet engineering support, so trying to support the fleet in both a distance and a hands-on fashion. There's a heavy training and manning effort to make sure the systems are manned properly and that the training for the systems is appropriate for the fleet, performing analysis over time to make sure that we don't have training gaps, developing curriculum, et cetera. There's a strong cyber component, primarily focused on maintaining the accreditations for the systems. There's again, a strong logistics support element to it. All the various factors of logistics are embodied within in-service engineering. There's a data management element, making sure that we're maintaining the data and making the data accessible. Some of these systems are in service for a very, very long time, and we need that historical data to be able to maintain them. So there's an element of that. Configuration management, another key element. Test equipment, tools, jigs, fixtures, again, making sure that from a maintenance perspective, we've got the tooling that we need in order to maintain the systems. Supply support is another significant aspect. And then finally, making sure that the Navy has the right repair facilities. So as you can see, it's a very broad focus for the Navy to maintain these systems once they are in service. For Keyport's perspective, what we tend to focus on in the in-service engineering department, also known as Code 40, we focus a lot on systems engineering. So reliability, maintainability, availability, software and hardware design, maintenance engineering, again, cyber, training systems, as well as the training materials themselves and the associated analysis to determine what the appropriate types of training are. Doing simple, or not simple things, but simplistically, COTS insertion and tech refresh. We have a heavy fleet technical support, distance support, on-site support, and installation presence. Heavy lifecycle logistics focus. And then we also support acquisition engineering, from engineering support as well as contracts management. And finally, one of the major services that we provide to the Navy is in obsolescence management, which is the analysis, prediction, and resolution of obsolescence issues for parts, and then real-time tracking and mitigation for those things. Within the in-service engineering department, we've been reviewing what our focus is and what we need to be positioning ourselves for the future with. And we've come around to the fact that our mission is to develop field sustain innovative solutions, maximizing readiness and effectiveness to dominate the undersea domain. And we want to do that through transforming the warfighting capability and sustainability of the future through rapid technology transition. So in light of that, we took a look at what today's Navy looks like. We have a very strong forward presence, but we have limited autonomy. We have battle space awareness challenges. We're budget constrained. We need to focus on warfighter performance. And we have a strong need for in-service system sustainment. We've identified some very disruptive technologies that we believe will be game changers. Unmanned systems, obviously. A big focus for us is starting to become sustainment and readiness in denied environments. COVID was a funny example of that, but we're having to pivot on how we do business today because we are in a much more limited environment, both getting on the ship as well as traveling to ships. So we're having to figure out how to do our job in a travel denied environment, and that was actually discussed briefly in the intro video. Data and target fusion. So data analytics broadly, both from a tactical data as well as a maintenance type data scenario or situation, are going to be disruptive technologies for the future of in-service engineering. Augmented and virtual mixed reality technologies, these again have the potential to be massive game changers for how we train sailors and how we maintain systems. Fully integrated product support is something that's coming quickly to us. Logistics systems, consolidating that data, performing deeper analysis on it than is possible today, and eventually in an automated fashion. And in really focusing on resilient architecture and software assurance. That's kind of the future of cyber going forward. So next 5 to 10 years, we're trying to focus on, again, resilient systems, maturing AR/VR technologies, and then also taking a look at emerging human-assisted technologies. Really trying to leverage all the data that we have through things like model-based product support, which is coming to improve forecasting and ensure material readiness. Remote diagnosis, remote distance support is going to be a thing that the Navy is going to be focusing on, and in Code 40 we will be focusing on. And then supporting unmanned systems, both the tooling and just the full life cycle support for unmanned systems, from facilities through test ranges through requirements generation and then really focusing on the in-service engineering aspect of it, but the full life cycle for unmanned systems. And Dave, I think that's what I've got today for the overview for Code 40. So back to you.
Great. Thank you so much, Dave, for providing that overview. And I just want to give a quick ground rules for today. We have different speakers that are going to be speaking right after Dave here, and I'll be introducing the speakers before they start speaking, and then at the end we're going to open it up for questions. Right now we have another poll asking how many of these engagements have you attended, and thank you so much for launching that and participating in that poll. And while that's going, I'm going to introduce our next set of speakers. And again, thank you, Dave, for providing the overview. But next up, we have Mr. Andrew Wenzel, who's part of the Human Performance Engineering branch, and Lisa Andrews, who's the Non-Tactical Information Systems branch. So they'll start speaking once the poll has concluded. And it looks like the poll has concluded. So with that, I'm going to hand it over to Andrew and Lisa.
Hey, good morning. Andrew Wenzel here. So I'm the branch head for code 411 in the 41 division. 41 division being Enterprise Systems Engineering, as you can see on the slide in front of you. We currently have 5 branches in the division. Mine particularly focuses on AR, VR, mixed reality, human system integration. We have a lot of focus on, one of the bullets that David Coleman put out of our future technologies. Lisa?
Hi, my name's Lisa Andrews. Good morning. I am the Code 415 branch head, and our focus is non-tactical information systems. We run the gamut actually of non-tactical information. We set up systems, IT systems, and we also develop software to support that. We are directly supporting the fleet. We have a help desk that provides direct fleet interaction, and we have most of the skill sets that you see here on this slide are ones that we leverage contractors for as well as government. The way that Code 41, our division in general handles contractors is we invite them to be part of our team. They are embedded with us. They sit in our spaces when we're allowed to sit in our spaces, and they are contributing members of a greater team. And that provides the ability for us to leverage the skill sets and knowledge base from both industry and government within the one team, which we all find to be very beneficial. If you look at the different skill sets that we have listed there, you'll see that we cover most of the current software development skills. We also have most of the current IT and cybersecurity tasks on our dockets as well. Let's see, so Andy, why don't you talk a little bit about what AR/VR has going on?
Yeah, so within the Human Performance Engineering branch, we're focusing on a significant number of current projects as well as what ways we can grow at Keyport. Picture yourself in the virtual reality goggles. We'll take current training maintenance requirement cards, MRCs, and convert them to a virtual environment where you could be interactive. The human system integration portion is how do we as humans integrate in a 3D environment, and how can we interact in a virtual world? If you consider touching something in a virtual world, there's really not much feedback, and that's where we're working in haptics. And you have a motor generated feeling of touching something in a virtual world, and it gives you feedback. So as we take training that exists in the fleet today and puts it into a virtual world, it's going to be an opportunity to save the government a considerable amount of money in a world of moving training to where the trainee is rather than taking the trainee to the training. It also allows us to safely apply training rather than hands-on dangerous equipment. We can do that virtually and allow us to learn from mistakes that would not cut a finger off, if you look at it that way. And it certainly allows us a lot of opportunity to integrate from a different mindset on how we can provide training to the fleet.
Very good, thank you. And then another piece I'd like to draw your attention to on the slides is if you look on the left side there, you'll see the services are listed. Those are the specific contract vehicles that we are leveraging in our division in Code 41. So we leverage an ILS ISE contract and the software support and information services contracts, and that they are currently providing us with a pretty significant percentage of our workforce, which we welcome. Let's see, as far as skills that are upcoming, skills that we are looking to use, we're maintaining in our division. We are looking to continue the cybersecurity continuum. We have a lot of work being done in secure technical information guide application, a lot of different things regarding obtaining and maintaining authorization to operate. That's what the ATO administration indicates over there. And then we also have quite a bit in just the general care and feeding of systems, as well as software development, as I mentioned earlier. Andy, do you have anything you'd like to add?
Now you see some of the skill sets that are listed to the right. This is very inclusive of the entire division as a whole. We utilize everything from master training specialists to 3D designers. As mentioned by Lisa, we have the 2 current contracts still left. But you can see it's a pretty broad stroke of the skill sets that we need to keep 4.1 running smoothly. And we're utilizing a lot of modern software, a lot of existing software, a lot of things that will enable us to grow fleet training to the next phase and really modernize what we can do for the fleet. Is that me ringing?
Okay, and I honestly don't have anything else to add at this time. David, do you, David Waltz?
Excellent.
Back to you.
Thank you so much, Andrew and Lisa, for providing information. Next up, we have Miss Jennifer Lamb, who's part of the Weapons System Engineering Division. Jennifer?
Good afternoon. As David said, I'm part of the Weapons Systems Engineering Division. Specifically, I am the logistics project lead for the lightweight torpedo program. Our division is represented of six different branches, engineering branches, in addition to foreign military sales branches, and we do have a IT branch as well. On the screen here, I've listed out some of the current contracts that we have going on, as well as we see for the future. So on the left-hand side, you'll see these services contracts that are currently in process. We have a couple of software service contracts for custom computer programming, to include some help desk support, testing for services, of repair of actual equipment, mechanical recertification of equipment that we have, and electrical recertification. As well as we do play a heavy role in the torpedo community on the hazardous waste and environmental cleanup process for cleaning and removal for hazardous materials. On the right-hand side, there's a breakdown of some of the manufacturing processes that we employ on contracts, both mechanical and electrical. So you will see some torpedo components specifically listed, as well as some pretty broad categories We do have some highlights to bring forth to you today, one specifically being some of the specific Epdm requirements for O-rings. We do, as I mentioned, we do interface with hazardous waste in auto fuel. And so we do have requirements, restrictions on material that are pretty extensive and have high weapon specification and performance specifications for the material. We do interface with some explosives components as well. So there are different qualifications and certifications on various contracts that we execute. We do also have electrical contracts, being printed circuit assemblies, semiconductors, and all-up test sets. So we do support not only the torpedo as a whole, but the test sets as well. So we have various test sets in varying sizes that are used for the support of the torpedo program that we execute as well. One of the things that a question that we do get is we at Keyport do support the all-up round torpedo production. So on this, you will see piece parts and components listed, but there are contracts that we execute where we are actually procuring on a contract the larger assemblies or an all-up round exercise torpedo. So I tried to break it down for you so you could see some of the piece parts that we buy. At any given time right now in our division, we have about 15 contracts that are active, and I have about 20 to 30 contracts that are currently in the waiting and will be executed within the next year and a half. So we do have a lot of contracts going on at any given time. And we have various from the manufacturing and the services side as well. So that's kind of the highlight of the engineering division here for the lightweight torpedo program.
Excellent.
Thank you.
Thank you so much, Jennifer. Next up, briefing the next portion is Ms. Stephanie Peterson from the Electronics Acquisition and Sensors Branch, and Sean Gallagher from the Electronic Systems Branch. So with that, go ahead, Stephanie and Sean.
Hi, Dave. Thank you. As Dave mentioned, my name is Stephanie Peterson, and I'm the Code 432 project lead for the technology insertion hardware contracts. And those contracts are awarded and administered here at NUWC Division Keyport in Code 432, our branch here. We support program offices, though, that are back east. The contracts, the technology insertion hardware contracts provide display, workstation, processor, and network system functionality for mission critical and essential systems on board submarine platforms. Each of the technology insertion hardware suites contain display and processor components arranged in specific system configurations to satisfy workstation, processor, file server, or other network requirements. The current contracts that we have, you can see on the slide, are the technology insertion hardware 1618 and 2022 contracts. Those are very large contracts that we have here at Keyport, and under 1618, we're in the final years of production for technology insertion 18. Under the 2022 contract, which was awarded just last year, we're finishing final design on TI-20 and working to transition into production on that contract. The contract supports several program offices. The two primary program offices are PMS 425 Combat Control and PMS 401 Sonar. The contracts require the contractor to design, develop, test, qualify, produce, deliver, and support the TIH hardware. And the hardware that's being produced can refer to anything from an advanced production unit, an engineering development model, LRUs, which are lowest replaceable units, cabling, configuration and upgrade kits, commercial off-the-shelf items, non-developmental items, spares, and full units. The only software we have under this contract is really for the purpose of testing the equipment. As you can see on the lower part of the left-hand side of the slide, we will be procuring a future contract for TIH 2426 but it's anticipated a separate industry day would be held, and that would be held by our program offices that we support back east. Thank you.
Great, thank you, Stephanie. And is Sean Gallagher on?
Yeah, this is Sean Gallagher.
Great.
I'm an engineer who works over in Code 433. We do electronic systems, and specifically we support legacy, do engineering support for legacy systems. One of them is currently the NUWC 2 Alpha, which is the communication comms unit between surface ships and submerged that follows State Nag 1074. That's, as it shows there, that's a future contract need we're going to be looking into in the next 3 years here, replacing it with some kind of what we call next generation Gertrude, a form fit replacement for that system that follows the same State Nag 1074 requirements. Yeah, that's us.
Excellent, thank you. All right, the next slide, we're going to have Mr. Ryan Soderlin from Submarine Acoustic Warfare Systems Branch. All right, go ahead, Ryan.
Hello, everyone. I hope you can hear me okay. My name is Ryan Soderlin. I'm the engineering lead with the Undersea Acoustic Countermeasures in-service engineering agent here at Keyport. I'll start off with some background on who we are and what type of work we do. We're the one-stop shop for all things related to 3-inch and 6-inch countermeasures and their launcher systems. So this includes fleet support, training, life cycle logistics, engineering and alterations and installations, configuration management, and sustainment engineering. Next slide, please. So our job is to make sure that when a submarine is in trouble, they have a working defensive measures. Our countermeasures come in 2 variants. There's 3-inch diameter devices that are launched by the sailor from inside the submarine using the signal ejector, and 6-inch diameter devices that are stored externally, housed in a tube, and launched using a slow-burning propellant when needed. Every few years, we put out an opportunity for building these devices using a build to specification contract. Typically preceded by an RFI to solicit and judge industry interest. Currently, we have contracts out to produce the 3-inch ADC Mark II Mod 7 devices and the 6-inch ADC Mark III and Mark IV Mod 1 devices. Additionally, the ADC Mark V is currently in development, and that's a newer 3-inch device countermeasure with advanced capabilities. You can see down below the smaller ADC Mark II, ADC Mark III, and ADC Mark V devices defend against incoming torpedoes, and the ADC Mark IV devices defend the sub from enemy sonar. In the graphic there, you can see the general shape of the devices. Building these requires design experience in underwater transducers, mechanics of launching devices underwater, automated control of devices underwater, high capacity batteries, high pressure sealing, custom circuit boards and software, and many other challenges. The smaller devices are the ADC Mark II and ADC Mark V, and the larger ones are the Mark IIIs and Mark IVs. In addition to these devices, we occasionally procure raw launch tubes for their storage and launch of the larger devices. And these are custom-made stainless steel tubes. They're about 10 feet long and 7.5 inches diameter, and that requires some custom tooling to manufacture those. Next slide, please. So for launch of the 6-inch diameter devices, there are many variants of our control system, known as the Countermeasure Set Acoustic, or CSA. The CSA system is the inboard operator-facing interface that allows for rapid programming and launch of these 6-inch devices. So these systems have to be extremely reliable and supportable. Considering the long life that our submarines have, supportability is important. These systems are built for new submarines, and we develop updates for in-service submarines. Work done in support of this includes support services for updating technical manuals, updating our drawing packages, changes to the TDP using engineering change proposals, and then installation procedures. We also have development contracts for updating our CSA systems and for producing our CSA systems. Many of these components within CSA are modified COTS, modified commercial off-the-shelf components, and a lot of it is fully custom hardware. It's a lot of electronics packed into small watertight sailor-proof boxes that are mounted inside the submarine, and everything has to undergo rigorous environmental testing to make sure it's suitable for the environment and safe, grade A shock, that sort of thing. While most of our in-service procurements are accomplished by NAVSEP, we do occasionally require prototype hardware for our sustainment efforts. This typically includes custom circuit boards, wiring harnesses, power supplies, junction boxes, test hardware, and related tools. And I think that about covers it for our group. Thank you. Back to you, Dave.
Great. Thank you so much, Ryan. Next up, we have Ms. Amber Harden from the Obsolescence Management Division. Go ahead, Amber.
Hi, good morning. Okay, so the Obsolescence Management Division. Go ahead, next slide, Dave. Okay, so the purpose of the Diminishing Manufacturing Sources and Material Shortages program, or DMSMS program, what is how we like to call it, is to identify, analyze, and mitigate DMSMS issues that have the potential to impact military systems when materials become unavailable due to obsolescence and the loss of manufacturing sources. Obsolescence issues are mitigated in alignment with whatever best meets the needs and requirements of the program, be that purchasing parts, finding new vendors, reverse engineering, redesign, etc. Next slide. Keyport is the DMSMS Center of Excellence. We have a multidisciplinary workforce consisting of highly trained and qualified logisticians, technicians, engineers, and other subject matter experts, all using common processes, collaboration, and organic tools such as our Obsolescence Management Information System, or OMIS, data analytics, and predictive techniques to find obsolescence issues before they have an impact on the ability to produce and sustain systems, and to determine and implement resolutions before parts and systems become unavailable due to those obsolescence issues. Next slide. So we are primarily a NAVC focused organization with most of our tasking focused on submarines and surface ships. For submarines, we support all classes, hull, mechanical, and electrical, HM&E systems, and participating acquisition resource manager, or PARM systems. For surface ships, we support primarily HM&E systems. In addition to our NAVC tasking, we work with NAVAIR, the U.S. Marine Corps, the U.S. Army, private industry, and other organizations. Next slide. So this slide talks to some of our more specific capabilities. Let's see, the first one here, obsolescence status. We compile manufacturers' part information through automated services and robust surveys, and provide real-time and forecasted obsolescence status and impact down to the configuration part number. Individual part status rolls up to show overall impact to the system. You can see a small visual there on the right-hand side at the top, where you can see the individual parts rolling up into subsystems into the overall system. Case management. We create and manage cases tracking progress towards resolution and capture metrics and cost avoidance, which you can see in the graphic on the bottom of the slide there on the right-hand side. We import supply data from NAVSEP and DLA to manage inventory and create watch lists and provide supply forecasting. And we identify and manage bills of materials using data that we receive from manufacturers, drawings, tech manuals, and the Navy Configuration Management System and other DoD organizations we collaborate with. Forecasting obsolescence. We forecast obsolescence and predict future obsolescence impacts. We can provide data visualizations to show obsolescence impacts to parts, subsystems, or particular functions of a system, and the overall system. Again, you can kind of see that on the top right-hand side graphic. And we can provide all sorts of customizable reports designed to fit the program's needs and focus. Next slide. So overall, our mission is to eliminate DMSMS risk to the warfighter readiness. And that's it for Code 46. Back over to you, Mr. Walls.
Awesome. Thanks so much. I want to thank all of our speakers. And before we open up for questions, I do see in the chat box there we have some questions. And I know Tiffany or Kathy will be passing off some questions to our speakers. But we do have one more poll question, a kind of a fun one that we could launch here, give our speakers a chance to get a sip of water before we start peppering them with some questions. So what is your favorite military war comedy? So we'll let that run for a few seconds and let Kathy or Tiffany give them a chance to start looking at the questions. Also on the line, we do have some subject matter experts that are available to answer some questions if need be. But with that, we'll go ahead and open up the question portion of our industry day. So with that,
thanks, Dave.
All right.
I think my internet has caught up to reality here, so I think I'm good to help facilitate the questions here. And if folks do have questions, feel free to pop them over into the chat. These slides will be available on the website, the Navy's website afterwards, and we'll give you a link of where you could find that. Give us a few days to put that up there. But I'll go ahead and start with the first question. It was early on in the speakers for David. David, can you provide examples of automated ILS?
Yeah, so thanks for the question. It's looking at supportability. It's looking at, obviously, as you just saw, obsolescence is a factor, but it's also looking at inventory failure rates and then trying to automate the analysis of when we'll run out of parts, when we might need to actually start looking at redesigns, those kinds of things. So it's taking in the maintenance data and inventory levels and failure rates and doing an automated analysis of that is one example.
Excellent, thank you. Another question from Kurt Warden. Are you using existing non-tactical networks, or is the Undersea Warfare Center bring on any new networks?
This is David. I'll take that one again. So in general, we've got several different networks at Keyport. They are non-tactical in nature. But for shipboard work, we are doing where we're transitioning some of these technologies on the ship. Some of these technologies are indeed on tactical networks on board ship.
Excellent. Thank you for that. Is the Naval Undersea Warfare Center moving augmented reality, virtual reality from training to augmented planned maintenance system cards? Do you know who would take that one if it's not you, David?
So our focus is on moving training from existing written documents. So these are the maintenance training cards or maintenance requirement cards, and converting those over to virtual reality interactive training simulations. So a lot of our problems center around converting existing vendor data, such as CAD models, over to content that can be run in a virtual reality system. So a lot of our problems that we're interested in are on solutions that can convert CAD models into polygon-based models that are well decimated and ready to be imported into a virtual reality simulation.
Excellent, thank you. This question is from Andrew, and it's from Buzel and Hamilton, Dawn. Can you talk about some of the programs you currently support in the Navy? They're interested in following up with you. They do a significant amount of immersive solutions for development across DoD.
Yeah, a lot of our, this is Andrew Wenzel from Code 411. A lot of our current projects are research-based, and we're doing a lot of internal, focus on supporting, again, research towards similar to what Phil just mentioned in concept. Some of our direct support is Keyport based in the submarine community, and I'd certainly be happy to communicate through the SBO and how we can implement future support.
Thank you for that. And we have two questions related to precious metals and hazardous waste. The first comes from George Lucas. Are there any precious metals contained in any of the waste products, including the hazardous waste? If so, is there a contract that exists to reclaim the metals?
So that's an excellent question. We do not have precious metals in the contaminated products that we are removing. So we don't have a contract in place for a reclamation of those metals.
Okay, thank you. And another question related to hazardous waste and environmental remediation. Do you have a need for fabric liners, berms, or spill containments? If so, how would a local fabric small business go about providing you with these types of supplies?
Also an excellent question. We actually do have need for fabrics and containments for personal protective equipment. And I would just state that if you have any of your contact information, if you make sure that David Walls has your information, he can specifically get it to myself. And I can make sure that the correct people are notified. We do have market research that we do post to Beta Sam to gain interest, and we can definitely make sure that your company has the information so that we can get in touch with you.
Excellent. And that goes for all the other attendees here. If you want to get in touch with somebody on the panelists, David Walls will type his information into the chat box as to how to get a hold of him. And your local PTAC can review your capability statement before you submit it over to David. Make sure that it has all the information that the Navy is looking for in that. I have 3 more questions so far. From Michael Coffey. Andrew, you mentioned that many software solutions and tools. What is the scope of your software development activity, the number and size of your teams?
Well, if you went back to, this is Andrew again, thanks for the question. If you go back to slide 3, if that's accessible to you, a lot of our software that we're working with currently is listed here. The size of our team here in just the branch, we're at about just under 20 folks working in various areas of research, as mentioned before. Phil, if you wouldn't mind, Phil Pitts, my SME and ARVR, if you wouldn't mind maybe elaborating a little bit on some of our software.
Yeah, sure. So we focus on building higher end training simulations. And so we use common game engines that are available in the private industry, such as Unity and Unreal technologies. Both of those have game engines that can support the type of high quality training that we try and develop. I mentioned before that we focus on converting existing vendor data over into configuration managed data that we put into our training simulations. And we convert those over from, like I said, CAD formats over to polygon-based formats. So those are like mesh-based model formats.
And I'm sorry, this is Lisa Andrews, also from.
Thank you for that, Philip.
Code.
Please.
Hi, this is Lisa Andrews, also from
Go
Code
ahead, Lisa. Thank you.
415. Thank you. I just wanted to add to what both Phil and Andrew mentioned. There are the other software development technologies that are being handled in our division include extensive Java development using Eclipse primarily as the IDE, the integrated development environment, C# using Microsoft Visual Studio, pardon me, as well as all of the usual technologies, HTML, the CSS, JavaScript, Ruby on Rails. I mean, we are using most of the different languages that are pretty commonly used out there, and most of the tools that we're using are industry standard, so it's not too far afield. The specialized areas that Andrew and Phil both mentioned are, I'd say, the more unique in our group, but otherwise we're pretty much correlating to the industry standard. Thank you.
Great. A question from Don to Ryan and Amber. For some of your ad hoc hardware material needs that may not be able to be executed in-house, what contracts do you use for one-off solutions, leveraging industry, labs, and infrastructure that are more agile as compared to Seaport E, for example?
This is Ryan Soderland. For Code 435, typically we try to procure things under the P card or purchase card limit, so we can just do a credit card buy. When things are more expensive than that, or we can't procure it under a purchase card, or they're electronics based, we have to go through our Code 02, our contracting division, to put out a procurement contract.
Yeah. And this is Jason Bolt here.
And those,
this is Jason Bolt from the DMSMS side. Same way with Ryan. Anything that purchase card goes out through that. Anything bigger than that goes out through FedBizOps and gets posted out there for any solicitations that we're looking for. So you should see them there. But other than that, we don't have any. We have looked into using some of the OTS, the other transaction authority or OTAs, but we haven't. We don't have any active ones at this point that we're actively using. So.
Very good, thank you. Torpedo components, this is for.
So this is an answer to the torpedo component question. So the gauge for the metal tank, so currently those tanks are used for a nitrogen cylinder, and we have a couple of different requirements, and I can get some of the specifications to you, but it is a pressure cylinder for nitrogen tanks. So I can pull up the specs. I don't have that off the top of the typical thickness for the gauge, but to give you an idea of what that requirement is.
Okay, this is Kathy. I'm checking to see if we've missed everything. Just a reminder, all this after it's gone through the POA office will be posted on the Keyport website. Okay, and I'm seeing that some of the past video links aren't working, and we are addressing that. Dave and I just chatted about that this week. Have we missed anything, panelists, that you've noticed?
Okay, well, thank you, Kathy. I don't see any other questions on there. So Kathy, Tiffany, thank you so much for managing the chat box for today. I also want to, again, thank all of our panel members and for David Coleman for just taking their time and putting those slides together and speaking, and also everybody who's behind the scenes who really put this together. Thank you so much for all your help. Before signing off, I'd like to thank the Washington State Procurement Technical Assistance Center for providing us the support and the platform for us to have our virtual industry day. We do have one more, so I hope those that joined us today will join us next week when we're going to have our acquisitions department, our contracts department, provide a briefing on all things contracts. Like we were just discussing, this session and all the sessions are being recorded, and we're going to post those on our website. We're actually talking about trying to get them on the YouTube channel as well. You know, if you do have any other questions, if any questions didn't get answered in this forum, please email my office, and I'll make sure those questions get answered. Also, if you would like to have a meeting with myself or a meeting with one of the panel members, contact my office as well, and I'll try to schedule something dependent on the schedules of our panel members. So with that, this concludes the session. Any parting words from our panel members or from PTAC? Okay, if not, thank you everybody who attended today's event, and hope you come back next week. Thank you so much, everyone.